Morning. Good morning.
Morning, sir.
It's audible.
Yes, sir. Audible.
Shall we continue? Shall we continue?
Yes, sir.
In the previous class, we have solved one problem because of rectangle transaction, and also we told you that remember the equation and this equation in the set. I am not told you how to solve this equation. Is nothing but the equation is for rectangle transaction is the form epsilon x equal to rectangular. This is the form epsilon is equal to sigma x by e minus 1 minus sigma x by e for this one extra transaction also. It remains the same. It is nothing but that epsilon x minus 2 times for that mu is equal to epsilon y by epsilon x or mu times epsilon x equal to epsilon y or mu times sigma x by e is equal to sigma x by e is equal to let me substitute here in place of epsilon y I will substitute this mu times sigma x by e and epsilon is to sigma x by e and 2 times mu times sigma x by e or if I write okay sigma x by e common epsilon is equal to sigma x by e. So it's another thing. To use this form as this form. Okay. This is sigma x by e for we go ahead. I'll be engaging two classes so that we can model for some problems with this steel rod, the steel rod of length 4 meters, length 4 meters, diameter 20 mm, 20 mm diameter, is subjected to an axial load of 40 N. Determine the change in length, diameter, and volume of the rod. Volume. Take Young's modulus C is equal to 2 into 10 power 5 Newton per mm square and Fazil section mu equal to 0. This is the problem. We need to find the change in length, diameter, and volume. As soon as we give change in diameter, it means to say that it is of circular cross section. It is of circular cross section. Change in length, as usual, the first step dl is equal to PL by AE equal to 40 into 10 power 3 into length 4000 by area of cross section 5 into 20 square 4 into Young's modulus 2 into 10 power 5. And tell me the change in length.
Sir, your volume is very low, sir.
Sir, can't hear you, sir.
Okay, now is it audible? Now
Yes,
it is.
sir.
Okay, ಮೊದ್ಲು ಹೇಳ್ರಿ ಈ ತರ ಇದ್ರೆ I have unmuted the mic here in my earphones. You should have been told me. Okay, tell me the change in length. I muted that. You should have been told me. Tell me the change in length.
2.54.
2.54 mm, right?
mm.
As DL, which is equal to 2.54 mm. We know that epsilon x, which is equal to DL by L. Okay, I know change in length, which is equal to 2.54 divided by length. It's a 4000 mm. Can you tell me what is epsilon x? Strain in x direction. For strain in x direction, you have to take epsilon. This one dl is equal to dl by L. Strain in y direction, delta d by d. Strain in z direction, delta b by b. Something like that only. We should not take epsilon y is equal to delta d by d. You might have been known that is a lateral strain.
Six 6.35 into 10 power minus 4.
Okay. 6.36 into 10 power minus 4.
55.
Okay.
6.35.
We also know that Poisson's ratio is equal to lateral strain by linear strain, which is nothing but equal to epsilon y by epsilon x, nu, which is given in the problem as 0.25. 0.25 is into 0.25 into 6.35 into 10 power minus 4 is equal to epsilon y. Can you tell me what is epsilon y?
1.6 into 10 power minus 4.
1.6 into 10 power minus 4. 1.6 2 into 10 power minus 4. Epsilon y, this is a lateral strain, delta d by d, 1.6 into 1.6 into 10 power minus 4 into original diameter, it's 20 mm. This gives delta d. Can you tell me what is delta d?
Three point two into 10 power minus 3.
3.2 into, so tell me with this delta d, see you can also include the sign if you want. Since there is a decrease in volume, as you pull this, there's a decrease in volume. If you want to include it, is obvious that, but some always will get confused. I will include the sign delta d. Since there is a decrease in volume, I will increase it. You can imagine that if I pull that in the other dimension, the dimension in that dimension decreases, the diameter decreases. You can indicate directly how much 2 point. Yes,
3.2.
3.2 into
10 power minus 3.
10 power minus 3. You can write directly decrease. Okay, and he has asked to find the volumetric strain epsilon v, which is equal to sigma x by e into 1 minus 2 nu.
Or that minus you won't write.
If you want to write, you can write it. You can write it in this way. You can write delta d is equal to minus 3.2 into 10 power minus 3, or delta d is equal to 3.2 into 10 power minus 3 decrease. Right?
Okay, sir. Okay.
It's understood that, but for explicitly writing that, we will write with negative sign. That is, there is a decrease in dimension. Sometimes we miss it. Like we think that this is the positive value, but always that I insist that we take the sign along that. Whenever there is a decrease in dimension, when we go to a future problem, further problems will come to know. Okay.
Yes, sir.
Epsilon v, which can also be written as sigma x by e as epsilon x into 1 minus 2 nu. Epsilon x is found to be 6.35 into 10 power minus 4 into 1 minus nu is 0.25, 1 minus 0.5, 6.35. You tell me the answer. Epsilon
3.17 into 10 power minus 4.
3.17 into
10 power minus 4.
10 power minus 4. Yes, who is that? Please mute your mic. Epsilon v 3.17 into 10 power minus 4. I can write this as, I'll be writing it here. Epsilon v, which is equal to delta v by v. Epsilon v 3.17 into 10 power minus 4 into pi into volume is pi d square by 4 into L, pi into 20 square by 4, pi d square by 4 into length. Length it is 4000 mm. Can you tell me what is delta v? Sorry, delta, yes, delta v. Yes, delta v.
398.15.
398.15 mm cube. It means to say that there's an increase in volume. Since the positive sign, there is increase in volume. That's it. These are generally asked for 6 marks, sometimes for 8 marks also. Okay, we'll go to the next types of problem. There is generalized types of problems. Hope you're understanding this, right? These are simple problems comparative to the other, that is a bar type. That is also simple. We have followed the convention, but this is also quite simple only. The problem statement is like this. A bar of 600 mm long, a bar of 600 mm long is having square cross section. Is having square cross section of size 50 mm into 50 mm. Depth is 50 mm. Width is also 50 mm. If the bar is subjected to an axial load of 120 kilonewton, as soon as it gives an axial load, that should be along the length direction, 120 kilonewton, 120 kilonewton, and lateral compression load of 600 kilonewton, lateral compression load of 600 kilonewton. Give me a minute. Lateral compression load of 600 kilonewton on faces 50 mm into 600 mm. So this is also 50 mm into 600 mm face. Lateral compression load of 600 kilonewton. Compression as he has given. Lateral compression. This is a lateral dimension. Since this is axial dimension, this is a lateral compression 600 kilonewton. For equilibrium, there should be also load along this direction 600 kilonewton. And also since this is also a phase of 50 into 600, this is also subjected to lateral compression of 600 kilonewton. That you should understand. 600 kilonewton. One phase, this is Z and Y and Z plane is subject to tension. Other two planes, other top phase, bottom phase, and side phases are subjected to compressive loading of 600 kilonewton. Okay, don't worry about X, Y, Z. Okay, this is the problem statement. Now he has given find the change in size and volume. Find the change in size. What are the changes? We need to find delta L, delta D, delta B. Find the changes in size and volume. Delta V is equal to how much? Given that Young's modulus C is equal to 2 into 10 power 5 Newton per mm square, and Poisson's ratio nu is equal to 0.3. This is the given problem. As usual, we'll solve step by step. Step by step. Stress in X direction, right? Stress in X direction, which is nothing but sigma X, which is equal to sigma X, Young's modulus times, or I can directly write load divided by area. Load is given to be 120 kilonewton, 120 into 10 power 3 divided by area of cross section. This area I should take, area of cross section for normal. This is the normal stress. You should take the area which is perpendicular to the load. This is the area which you should take. This is the area you should take, and this area is nothing but this is 50. This is also 50. 50 into 50. Since this is a tensile load, tell me what is the magnitude of your stress in X direction. What is the magnitude?
$48.
48 MPa. You should tell along the units.
48 MPa.
Or 48 Newton per mm square. 48 Newton per mm square. Right, like that only. Positive means tensile. Stress in Y direction, sigma Y, since the load is compressive, minus P by A, which is equal to load is compressive minus 600. You can write, if you are confused with that, leave it. Since the load is compressive, minus 600 into 10 power 3 by area of cross section, this area. Is perpendicular to that, this area. It is your 50 into length, 50 into 600. Tell me what is sigma Y, which is equal to
minus 20 MPa.
minus 20 MPa. You should write like this, minus 20 Newton per mm square. Sigma Z, which is equal to P by A, which is equal to P by A, which is equal to minus 600 into 10 power 3 divided by this area of cross section. This area of cross section, load is perpendicular to that. 6. This is also thickness is 50, length is 600. 50 into 600, which is equal to minus 20 Newton per mm square. Okay. He has asked us to find the change in length, depth, width, and the change in volume. Okay. Change in length. Change in length. I can do it as epsilon x, which is equal to, I will write the generalized Hooke's law formula, sigma x by E minus nu times sigma y by E minus nu times sigma z by E, which is equal to, you write it 1 by E into sigma x, it's 48 minus nu is 0.3, sigma y, it's minus 20 minus nu is 0.3, sigma z minus 20. Tell me what is divided by, this is E is 2 into 10 power 5. Tell me what is epsilon x.
Thirty into 10 power minus 5.
Okay, shall I write 3 into 10 power minus 4? One and
Okay,
the
sir.
same. 3 into 10 power minus 4. Epsilon x, which is equal to change in length. Directly, if you want to write dl by l also you can write, or 3 into 10 power minus 4 into length is 600 mm, which is equal to delta L. Can you tell me what is delta L? I'll write directly. It's 0.18 mm. 0.18 mm, since it's not a negative sign. 0.18 mm. There's an increase in length. Increase in length. Right? Increase in length. Okay. Next, we'll go for epsilon y. Epsilon y, which is given by sigma y by E minus nu times sigma x by E minus nu times sigma z by E. Sigma y, I'll take 1 by 2 into 10 power 5 into sigma y, it's minus 20 minus 0.3, 0.3, right? 0.3 into sigma x is 48 minus 0.3 into 48 minus 0.3 into minus 20. Tell me what is epsilon. There is no need to change the formula. Only whatever the stress you will get with magnitude and sign, you substitute that. Your answers will be right. What they will do, the authors will do, they will change this formula itself. This is the whenever there is a compressive loading, this what happens is this sigma y will become sigma y will become minus sigma y, and this sigma z they will change it to plus sigma x minus sigma z, like that. Don't, no need to worry about it. Okay, whenever there is a tensile, they will take positive. Whenever there is a compression, they will take negative. You take when with the this one with the values you can change the sign, not with the formula. Don't do that because it will be confusing. No need to write that also. Okay, directly with the values. Whenever there is a tension, you write positive. Whenever compression with the sign, you write it as negative. That's it.
Minus 1.42 into 10 power minus 4.
Right. What does minus indicates? What does minus
Decrease.
indicate? Decrease. Width is, this is depth is decreasing. Minus 1.4 into 10 power minus 4. Okay. Therefore, epsilon y, which is equal to delta b, sorry, delta d by d. He has written simply x, y, z axis. No need to worry. You do whatever the area of cross section you have taken. Since the area of cross section what I have taken is perpendicular to this load. If this is my 600 kilonewtons, this is perpendicular to 600 kilonewtons. That means that it is the y-axis. Then there is a change in depth. If this is that I'm talking about this, then this is the change in width. That you should understand that. Okay. Delta d by d, which is equal to minus 1.42 into 10 power minus 4 into uh, uh, depth in the sense is 50 mm, not diameter. It's 50 mm is equal to delta D. Can you tell me what is the change in depth? Shall I write directly? Delta D
0.007.
0.007. Shall I write 0.007 minus 0.007 mm or 0.007 mm decrease in depth is in depth. Okay. Epsilon z, which is equal to, as soon as you write epsilon z, take the linear strain first term sigma z by e, and all other terms with Poisson's ratio minus nu times sigma x by e minus nu times sigma remaining terms with Poisson's ratio. Sigma z by e 1 by 2 into 10 power 5 into sigma z, it's minus 20, right? Minus 20 minus 20 minus 0.3 into 48 minus 0.3 minus 0.3 into minus 20. Tell me what is epsilon z.
Same, sir. Minus 1.42 into 10 power minus 4.
Yes, lateral strain are same. Epsilon y and epsilon z are same. Okay, minus 0.007 mm with the negative sign. Okay, or decrease in that. Okay, now he has asked us to find your epsilon z, which is equal to delta b by b minus 0.007 into width is also 50 m is equal to delta b. Delta b is also equal to how much this? How much this is 1 point minus 1.42, right?
Yes, sir. Minus
Minus
1.42.
1.42 into 10 power minus 4 minus 1.42 into 10 power minus 4 or delta b, which is equal to minus 0.07 mm. This is also decrease in dimension. Okay. Now he has asked us to find, we have found delta L, delta D, delta B. We are left with volumetric strain delta V. Sorry, no, change in volume. For that, we need to calculate volumetric strain. Epsilon V, which is equal to, can you recall the formula? Volumetric strain. Sigma x plus sigma y plus sigma z by E into 1 minus 2 nu. Okay. Or you can directly write. You can also directly write epsilon x plus epsilon y plus epsilon z, or which is nothing but equal to. You can always one on the same. It's nothing but equal to 3 into how much? Epsilon x is 3 into 10 power minus 4. 3 into 10 power minus 4 minus 1.42 into 10 power minus 4 minus 1.42 into 10 power minus 4. Can you tell me what is epsilon v?
1.6 into 10 power minus 5.
Or shall I write 0.16 into 10 power minus 4? Volumetric strain is given by change in volume by original volume. Original volume for rectangular cross section, length, width into thickness LBD. LA is 600 into 50 into 50. Can you tell me the volume? 6 5 30 30
15 into 10 power minus 5. Into
no,
10 power plus 5.
15 into 10 power 5 cube.
mm3.
Yes, epsilon v 0.16 into 10 power minus 4 into 15 into 10 power 5 is equal to delta v. Or tell me what is delta v?
$24.
24 cube. If you ask the final volume which is equal to uh, final volume is equal to initial volume plus change in volume. Initial volume is 15 into 10 power 5 plus change in volume is 24. Final volume is equal to how much, you tell me?
One five zero 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 two four.
150024 cube.
00024.
150024. That's
Then
it, right?
00024.
000. Okay.
150024.
Okay. 24 cube is the final volume. This carries 10 months. Okay. Next hour also I'll be engaging. I'll complete this generalized Hookstop part problems, and we'll start with from the next class from tomorrow onwards. We'll be solving problems on this one. That Young's modulus Poisson's ratio, that constant problems will be solving. Okay. I'll stop at this point. Any doubts you can ask me. Any doubts you can ask. These are the problems. If in case, if the loading is tension, I have done with the compression part. If the loading is instead of 600 kilonewton compression, the 600 kilonewton is tension and this lateral faces, then there is this, all this become tension. Only thing you have to directly substitute the formula, this given formula in our formula, and you can obtain the answer. It's the same thing holds good for this type of problems. Okay, then in the next class from 11:30, we will be solving some typical problems on this. Sometimes if if there is no no room for expansion in lateral direction, how the problems can be solved. If there is no change in volume, what type of problem, how to solve. We'll solve another 2 types of problems, and we'll complete this. Okay, any doubts? Any doubts?
No, sir.
Okay, I'll stop at this point. At 11:30, we will be engaging the second. I'll be engaging the second hour. Thank you.